trying to stay on top of things and, well, any field can feel like a constant uphill battle, right?
Absolutely.
Especially in an industry as foundational and, always evolving as
It
construction.
was so fast sometimes.
So today we're diving deep. You sent us a chapter called A Changing Industry, and our mission really is to cut through the
Get
noise.
to the heart of it.
Yeah, get to the core. What are the big shifts happening in construction, and, well, why should you care? Consider this your express lane to understanding what's actually going on.
And what's really striking in this chapter, I think, is the recognition that construction isn't just about, putting up buildings anymore.
Right.
There's this really interesting mix of pressures that's fundamentally altering how we approach, well, every single stage of a project.
Okay, so let's jump right into maybe one of the biggest shifts, something we're all hearing more about, sustainability.
Mm-hmm.
The chapter really highlights a significant evolution in thinking it's not just about ticking boxes for minimum code anymore.
Not at all. There's a much deeper understanding now of the profound impact buildings have.
On us and the world around us.
Exactly. From energy use, resource depletion, even our own well-being inside these buildings.
So the industry's response, as this chapter outlines it, is this rise of sustainable construction.
Right. Or you might hear it called high performance or green building. They're often used interchangeably.
And what does that mean, really?
At its heart, it's about actively trying to minimize or even, eliminate our reliance on fossil fuels.
Okay.
Being incredibly thoughtful about where materials come from, prioritizing non-toxic substances, and really safeguarding the natural environment.
And this isn't just like wishful thinking, is it? Interestingly, the chapter points to studies, multiple studies, apparently that actually quantify benefits.
Oh yeah, the data's there. Lower long-term running costs for the buildings themselves.
Which owners love, I imagine.
Of course. And healthier environments for the people inside, plus these broader positive effects on the community and the environment overall.
And it seems like demand is really, really picking up. The chapter mentions this incredible growth in certified green buildings.
It's huge. From something like 30 million square feet back in 2000 to, well, billions today. Literally billions.
Wow. So what's driving that kind of surge? Is it just consumers wanting it?
That's part of it, but what's truly insightful here is how this demand is shifting the whole supply chain. Traditional manufacturers are scrambling to offer greener options.
Right.
And entirely new businesses are popping up to fill specific niches in sustainable materials and tech.
But connecting them to the bigger picture, government.
Government entities are playing a massive role. Yeah, they control huge amounts of property, massive construction budgets.
Federal, state, local.
All levels. And the chapter really emphasizes that the strong economic case for green building is leading many of them to actively promote, sometimes even mandate, these high-performance standards.
Which naturally has a ripple effect across the whole industry.
Exactly. It forces everyone else to adapt.
That makes perfect sense. And the focus on our health indoors, that's a critical piece too, isn't it? The chapter talks about steering clear of harmful chemicals.
Right. And things like paints, adhesives, carpets, materials that can release these volatile organic compounds.
VOCs.
VOCs, yeah.
Why are there such a concern in building materials?
Well, they can off-gas, seep into the indoor air.
Yeah.
And they contribute to a whole range of health problems.
And respiratory issues?
Respiratory issues, allergies, maybe even more serious long-term effects. So the emphasis on non-toxic materials, plus making sure you have good ventilation systems for air quality, that's a huge driver in this shift.
Okay, so we have this big philosophical shift towards sustainability. But how does that actually, translate into changes on the ground, how buildings are designed and built?
Yeah, the chapter gives some specifics. One of the most significant is the need for much closer collaboration right from the very start of a project.
So not the traditional approach where everyone works in their own little silo.
Exactly. That doesn't really work if you're aiming for these ambitious performance goals. It needs deep commitment and really seamless cooperation between the design teams and the construction teams.
At every level.
At every level. And the chapter even hints that this level of integration, well, could be a bit of an adjustment for people used to the old ways.
I bet. And it sounds like the sustainability push is also bringing in a wave of new materials and technologies.
Oh, absolutely.
Which I imagine comes with its own set of challenges.
Precisely. What's fascinating there is the learning curve involved. Contractors, tradespeople, they need to get familiar with how to install these things properly.
And understand the costs.
Understand the potential cost implications, yeah, and even anticipate the long-term maintenance needs for these products that might be, well, pretty unfamiliar.
And then there's the paperwork, right? Proving you're actually meeting these green standards.
The documentation. Yes, the chapter talks about the increased documentation needed for certifications for incentives.
So it's not just using the right stuff, you have to prove it.
You have to be able to verify that the materials, the products, the systems all meet the specific program requirements. It adds a whole layer.
And this must mean roles are changing within the workforce, too.
Definitely. As the chapter points out, specialty trades, think HVAC techs, electricians, plumbers, they increasingly need specialized training.
For things like solar panels.
Things like solar photovoltaic arrays, exactly. But it's not just the high-tech stuff. Even seemingly common materials might be restricted or need specific documentation on green projects.
And it's not just the folks out on the site, is it?
No, not at all. The chapter makes it clear this touches everyone. Estimators have to account for the costs of sustainable materials.
Specifiers need to know what products meet the standards.
Right. And even the facility and maintenance workers, they need to understand how to actually operate and maintain these high-performance buildings properly.
So it sounds like green credentials, green training, that's becoming way more important across the board.
Increasingly important, yeah. Along with just staying up to date on all the regulations, which are also changing constantly.
Okay, so sustainability is a huge piece of the puzzle. What's another major force reshaping construction according to this chapter?
Well, the chapter then dives into the equally critical area of changing codes and regulations.
Right, the rule book.
Exactly. At their core, these are about setting minimum standards, public safety, health, general welfare of communities.
Like plumbing, electrical, structural stuff.
Yeah, the basics, often adapted from model codes that experts develop.
And the really important point the chapter makes is that these codes aren't static, are they? They're always changing.
Constantly being updated, based on new research, new data, or sometimes in direct response to big events like natural disasters.
And governments are using them more strategically now, too.
Increasingly. Leveraging codes as a tool to advance broader policies, like making communities more resilient or protecting the environment.
The chapter makes a useful distinction between standards and codes.
Right. Standards often start as voluntary guidelines, maybe best practices, but then they can eventually become mandatory requirements written into the building codes.
And we've definitely seen a trend towards stricter environmental rules.
Oh yeah, especially since the 1970s, particularly around energy efficiency, water efficiency, and cutting down greenhouse gas emissions from buildings.
The chapter gives us some concrete examples, like California's Shale Green Code,
which was the first statewide green building code in the U.S., a big deal.
And then there's the International Energy Conservation Code, the IECC.
Yeah, the IECC. That's a key model code recognized by the Department of Energy, and it gets updated every 3 years, so it keeps evolving.
It's also kind of sobering to remember the historical link the chapter makes between disasters and codes getting tighter.
It really is. Those examples, the Chicago fire, the San Francisco earthquake, Hurricane Katrina, those tragedies directly led to significant improvements.
In things like fire safety, seismic design.
Egress, yeah, safe ways to get out of buildings. Codes often learn from failure, unfortunately.
So when we talk about all these changing codes and regulations, what's the practical impact day to day for the industry?
Well, the chapter outlines several key areas. It affects pretty much everything.
Costs, I assume?
Costs, definitely. Project timelines, the specific installation methods you have to use on site, even the administrative side, the paperwork.
So contractors really need to stay on their toes.
Absolutely. They need to be proactive, stay informed about the evolving rules, and understand all the associated inspection and testing procedures to make sure they're compliant.
These evolving regulations must create new demands on the workforce too, which leads us to the next point. Demographics.
Yeah, let's explore how the demographics of the construction industry are also undergoing some pretty significant transformations.
Absolutely. The chapter highlights some really interesting shifts. It's an aging workforce overall. That's one thing.
Experience heading towards retirement.
But it's also becoming more diverse. More women, more minorities entering the field.
Slowly, yes. But the chapter also points out fewer people are advancing without some kind of academic education. Basic reading, writing, computer skills, they're becoming essential.
Not just nice to have.
No, must-haves.
Yeah.
And it's more common now for superintendents, managers, to actually have degrees.
And while the industry is still, mostly white and male.
Predominantly, yeah, as the chapter indicates.
Yeah.
But we are seeing a noticeable rise in workers from non-traditional backgrounds.
The statistic about foreign-born workers was striking.
Around 30% in certain trades like painting, drywall, masonry, even higher in states with large immigrant populations.
Which, while bringing valuable skills, also presents some challenges.
It does. The chapter points them out: language barriers, cultural differences, maybe different understandings of methods, or, importantly, safety protocols.
Things that need careful management.
Effective communication and training become critical.
And the chapter doesn't really shy away from the fact that some groups are still very underrepresented.
No, it doesn't. The numbers for women, still under 3% after decades. That's pretty stark.
And other minority groups are also quite low.
Blacks under 7%, Asians barely over 1%, and the chapter even mentions a report highlighting barriers like harassment, stereotyping, lack of mentorship for women.
So representation is still a major issue. And then there's the overall supply of workers.
A huge concern. The chapter talks about the impact of the Great Recession, tons of jobs lost, and less than half those workers came back.
Even when the industry recovered.
Even when it recovered. Plus, you have the experienced baby boomers retiring. It's created this real shortage of skilled tradespeople.
There was a survey mentioned.
Yeah, an AGC survey finding 70% of firms struggling to find qualified workers. 70%. That really underscores how serious this is.
So what are companies doing about it? How are they trying to tackle this labor shortage?
Well, the chapter lists a range of strategies. Using social media more, going to job fairs, actively recruiting veterans.
Trying to broaden the pool?
Exactly. And emphasizing the quality of life a construction career can offer, plus providing more training and clear paths for advancement.
There was a quote about knowledge transfer, too.
Right, from Skanska USA, highlighting the critical need not just to replace retiring senior staff, but to actually transfer their decades of knowledge effectively to the next generation. That's a challenge in itself.
What's fascinating, too, is the perception issue. Fewer young people choosing the trades.
Yeah, the chapter touches on that. Millennials aren't readily replacing the retirees, it seems. Maybe this perception that white-collar jobs are more respectable.
Or higher paying, safer.
Right. That perception exists. And there's mention of high schoolers phasing out vocational programs, pushing everyone towards four-year degrees instead.
Someone was quoted on that, Marianne Cusado.
Yes, making that point about the shift away from vocational training in schools.
And the chapter also briefly looks at the role of unions in construction.
Historically significant, lobbying for things like the 8-hour workday, collective bargaining.
But their influence has declined.
It has, yeah, for various complex reasons. The chapter notes the current unionization rates are pretty low overall in the U.S. workforce.
Around 11%.
Yeah, and just over 13%, specifically in construction as of a few years ago. But the chapter also points out there's still an ongoing discussion.
About what role unions could play now.
Potentially, yeah. Advocating for workers, maybe taking on new roles like administering benefits. It's an ongoing debate.
Okay, let's switch gears now. Another really transformative force mentioned is technology and new materials.
Huge impact, absolutely. The chapter makes it clear technology isn't just for the mega projects anymore.
It's everywhere.
Increasingly integrated into, well, every aspect, from initial planning right through to completion and even building operation.
We're seeing the rise of smart buildings.
Definitely, using IT to optimize performance. The chapter explains how these systems can control lighting, HVAC, based on who's actually in the room.
Saving energy.
Saving energy, proactively identifying maintenance needs, even responding to energy market signals to adjust usage.
And tech is pushing design boundaries, too.
Absolutely. Enabling the construction of buildings that were, frankly, impossible before, like Frank Gehry's amazing curvilinear designs.
And construction management software. That's been a real game changer, hasn't it?
Oh, completely. The chapter lists all the functions, estimating cost tracking, scheduling, procurement, all made way more efficient by digital tools.
Moving away from paper.
Moving towards integrated software platforms, cloud computing, meaning project info is more accessible, more up-to-date, anytime, anywhere. It's a huge leap from endless phone calls and stacks of drawings.
And drones are mentioned, too.
Yeah, the increasing use of drones for things like aerial surveying, site mapping, video progress reports. It gives you data capture that was way more difficult and expensive before.
The chapter lists some specific software packages.
Yes, several leading examples are mentioned, showing the variety of tools available now.
And beyond just management software, the actual construction tech is getting more sophisticated.
Very sophisticated. Yeah. GPS-guided equipment, robotics for certain repetitive or dangerous tasks, even virtual reality for planning, training, visualizing spaces.
And then there's BIM, building information modeling, Can you explain that a bit for anyone unfamiliar?
Sure. Think of it less as just a 3D drawing and more like a central intelligent database for the building.
So more than just geometry.
Way more. Every component, a steel beam, a window, a light fixture, has information embedded in it. Manufacturer specs, cost data, installation details, energy performance.
And what's the big advantage?
Well, you can detect clashes, like pipes hitting ducts, before you even start building. Saves huge amounts of time and money.
Okay.
And the chapter points out how valuable BIM is for analyzing code compliance, costs, scheduling, and crucially, keeping all that info updated automatically when changes happen.
And it's not just for huge firms anymore.
No, the chapter notes its use is definitely expanding to firms of all sizes. It's becoming more mainstream.
It's fascinating how these tech advances link back to sustainability, too.
They really do. The chapter points out that the drive for energy efficiency and reducing environmental impact is also fueling the development of really innovative new materials.
Driven by necessity, like rising energy prices.
Exactly. And concerns about greenhouse gases. So we're seeing things emerge like, well, carbon-trapping concrete.
Seriously?
Yeah, zero-carbon drywall, energy harvesting glass, panels made from agricultural stuff like sorghum stalks, even air cleaning paints.
Wow. Futuristic stuff.
Some of it sounds like science fiction, but it's becoming reality. And as the chapter emphasizes, contractors need to get ready to work with these new, often very different materials.
It really drives home the point that the old image of a contractor just being about manual labor, that's outdated.
Completely. Computer literacy, comfort with tech. Those are essential skills now for managers and workers alike.
Okay, another important area the chapter covers is waste management.
Right. An increasing focus here. Minimizing waste generation, handling it properly, disposing of it correctly. That's getting more attention on all projects, green or not.
And especially on green projects.
Especially there, yeah. The chapter highlights a specific focus on using fewer materials to begin with and prioritizing materials that are recyclable or just last longer to cut down on long-term waste.
And local rules are playing a part.
Definitely. Many places are implementing stricter recycling laws. Plus, landfill costs are rising, which also drives the need for more careful waste sorting on site.
Are there federal rules too?
There are federal regulations on waste disposal, yes. And often state and local authorities have even tougher rules, especially for hazardous or toxic materials.
So it's becoming an expectation for everyone on a project.
Pretty much. Responsible waste management is increasingly just part of the job description for everyone involved.
Let's talk about something that hits everyone's bottom line. Costs.
Yes. Costs.
The chapter notes this clear upward trend in U.S. construction costs, cites a specific index showing significant annual increases recently.
Yeah, the Turner Index. And homeowners doing renovations certainly feel it too, don't they? Rising material costs, labor costs.
So what's behind it, according to the chapter, beyond just general inflation?
Well, it breaks down several factors. Those stricter codes and regulations we talked about, they add costs for compliance, for inspections.
Makes sense.
The workforce shortages we discussed. That drives up personnel costs, wages, benefits as companies compete for talent. And those costs get passed on to clients.
Right.
Plus, the chapter mentions rising costs for specific materials, glass, lumber, rebar, and manufactured components, and longer lead times for materials because demand is high and maybe production capacity is strained.
It sounds like even global events can ripple through costs.
Absolutely. The chapter highlights how localized building booms, say after a natural disaster, can suck up available materials and labor,
Causing shortages elsewhere.
creating shortages and driving up prices in other regions,
Yeah.
And really, major global events can cause widespread material shortages.
What else contributes?
Tighten environmental standards, things like erosion control, dealing with toxic materials, add cost to practices, permitting, testing, and even just increased public involvement in planning and design can add time and expense to projects.
Okay, finally, the chapter touches on globalization.
Right. This increasing flow of skills, products, companies across national borders.
A big change from the old days of the local master builder.
A huge change. Today, as the chapter illustrates, big construction projects are often truly global efforts.
How so?
Multinational ownership, international design and engineering firms, fabrication happening overseas. Even the construction companies themselves might be foreign-owned.
The chapter uses Turner Construction as an example.
Yeah, a prime example. Their history of growth, acquisitions, global operations, and now being owned by a German company. It really shows the trend.
And this isn't just affecting the giant firms.
No, the chapter emphasizes it impacts U.S. companies of all sizes. It means increased competition, even for smaller, local contractors.
Because these big global firms can work anywhere.
They can work on complex projects anywhere, shift their workforce globally as needed. It puts a certain competitive pressure on the whole industry, top to bottom.
So to kind of wrap it all up, this chapter really paints a picture of an industry in, well, significant transition.
Massive transition, yeah. Driven by this powerful combination of forces we've walked through.
The push for sustainability,
The evolving codes and
the
regulations,
changing face of the workforce,
the rapid adoption of new tech and materials,
changing expectations around waste,
the persistent rise in costs.
and this increasing globalization.
And they're not isolated trends, are they? They're all influencing and reinforcing each other. It's complex.
Exactly. And for you, our listener, whether you're deep in the construction world, maybe planning a project, or just, curious about this fundamental part of our economy.
Understanding these interconnected forces gives you a really valuable perspective, I think. Hopefully, this deep dive has shed some light on the key dynamics at play.
Absolutely. And while it's definitely a lot to take in,
It is a lot.
hopefully this overview gives you a solid understanding of the major shifts underway without feeling too overwhelming.
So maybe here's a final question for you to consider, to mull over. Looking at all these interconnected changes we've discussed,
Sustainability, regulations, demographics, tech, costs, globalization.
yeah, all of that, which single factor do you believe will ultimately exert the most profound, the most lasting influence on the future of how we build our world?
That's a good one.
It's worth pondering, isn't it? How these forces will keep interacting and shaping the buildings and infrastructure around us for years and years to come.